theta is equal to 1. In 6.2, I did this problem by moving the cosine of theta to the right side and solving it out. I looked at some examples. I spent about 5 minutes looking at the examples, all of the examples from this section to see how they worked it out. So I try to mimic what they did. What they did in this problem, I believe I'm going to reference it to, where is it? It's going to be example 6. So you can use example 6 as a reference. They said, oh my goodness, it is the same exact problem. But I'm going to try not to copy it, so I'm going to put it away. First thing that they did was they squared the left side. Instead of moving this guy over, they just squared the left side and squared the right side. You have to pull this out. I'm going to write it in short term. Sine minus cosine times sine minus cosine is equal to 1 squared is 1. Sine, you have to pull this out. Sine squared minus 2 times sine times cosine plus cosine squared is equal to 1. You notice that sine squared plus cosine squared, that's the Pythagorean theorem in trigonometric form. So we know that this plus that sine squared plus cosine squared equals 1. We substituted 1 minus 2 sine of theta cosine of theta is equal to 1. We subtracted. That gets rid of that. Negative 2 sine of theta cosine of theta is equal to 0. At this stage, what you could do is you can set each factor equal to 0, but I don't think that's the way they did it because I turned the page. I think the way they did it is, this is a known. This looks familiar to you guys, doesn't it? It's the double angle. Just this portion right here. So that becomes negative sine of 2 theta is equal to 0. We divide by negative 1 to both sides. Sine of 2 theta is equal to 0. When is the angle equal to 0? At, let's get 36 again. The problem, I want theta between 0 and 360 degrees. Okay? So it's going to be between those two numbers. The sine of the angle is equal to 0. At 2 theta is equal to 0 degrees and 180 degrees. Let's read the question one time. 36. Oh. Number 36, it says find all solutions between this restriction. This 2, that means you have to do 2 rounds. 0, 180. I add 360 to this, becomes 360. I add 360 to this, that becomes 540. And that's equal to 2 theta. Solving for theta, divided by 2. Theta is equal to 0. 180 divided by 2 is 90. 360 divided by 2 is 180. And 540 divided by 2 is 270 degrees. And so we're done. Right? Right, guys? From the previous section, you should have learned something. That when we square both sides, you got to check for extraneous solutions. I put this in orange just to show you that we square both sides. So it's no other marker except for this one. I kept this in mind. So when you square both sides, as you're doing the problem, as soon as you see this, highlight it, bold it, so that you know that when you square both sides, you have to check for extraneous solutions. So let's try it. We're going to plug in 0 first for theta. Sine of 0 is 0. Cosine of 0 is 1. 0 minus 1, negative 1. Whoops, didn't work. what happens is, here's the intuition. When you go -1 squared to both sides, if this is -1, this is +1, you square it, 1 does equal 1. But before we square it, we have to check so that you don't get like 1 equals -1. That's the intuition behind the squaring. Okay? Because if you square it, you get 1. You square it, you get 1. The original problem did not work. Let's try 90. Sine of 90 is 1 minus cosine 90 is 0. 1 minus 0, 1. Perfect. That checks out. 180. Sine of 180, I'm sorry. I'm going to put 180 in here. Sine of 180 is 0 minus cosine 180 is -1. 0 minus -1 is +1. That checked out. Perfect. Let's try 270. Sine 270 is -1 minus cosine 270 is 0. -1 minus 0, -1. That does not work out. So your final solutions are 90 degrees and 180 degrees. Make sure you're cognizant of the fact that when you square both sides to work it out and then go back to the problem, and make sure you keep this in mind when you finish the problem. Okay? Next set of problems. The last one, I believe, that we're going to be doing today is going to be, we just did 36, so we're going to do 41. For cosine square of 3 theta minus 8 cosine of 3 theta plus 1 is equal to 0. Looking at this problem a little bit, it's a little bit tricky. First, you have 3 terms, a trinomial. The leading term, right over here, it's got a square on it. Square quadratic. So we're probably going to have to factor this if you can. Let's see if we can factor it. Step 1. Step 2. The factors, it's kind of like this. 4, it kind of looks like, I'm going to put a little cloud right here. 4x squared minus 8x plus 1 equals 0. If we're going to try to factor this, it's going to be, that's step 1, 2x and 2x. You could have also tried 4x and 1x. That's not going to work, I guarantee that. Step 3, the plus tells you they're both same sign. This tells you that they're both going to be minus. And the factors of 1 is 1 and 1. Let's see if that worked or not. Didn't quite work. Oh, sorry, probably didn't factor. Yeah. That's going to be 4x squared minus 2x is minus 4x. So even if you tried 4 and 1, 4x and then 1x, and then minus 1, that's going to be minus 5x. It does not factor. Too bad. So what I'm going to do here at this stage is use the quadratic formula. This is kind of like your A. This is your B. That's your C. So the quadratic formula, in our case, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I'm going to use a program in my calculator right over here. I don't know yet. You can probably see it. Sometimes the brightness in the way. There's a lot of, if you Google programs for TI-84 for the quadratic formula, you can probably find it online somewhere. Okay. The quadratic formula, I made this program myself though. It's going to be 4, negative 8, and 1. I'm going to get a value of x is going to be 1.866. X is equal to negative, no positive, 1.13397. Okay. So our x was, in this case, cosine of 3 theta. We know that the cosine theta is equal to 1.866, or the cosine of 3 theta is equal to 0.134, approximately. Okay. Whatever angle it is, the restrictions for that angle, the cosine has to be between -1 and 1. The cosine of 3 theta has to be between -1 and 1 inclusive. We know that it cannot become greater than 1, so we got rid of that. I don't know, 41, let's look at it. Let's see, it's going to be, theta is going to be between 0 and 360 degrees. That's our restriction, so it's going to be in degrees. So 3 theta, I'm going to use my calculator on this one. This is a lot of work. The reference angle, I'm going to find the reference angle first. It's going to be cosine inverse of 0.1134, and that looks like it's in degree mode. Let's check it out. Yes, it's in degree. Okay, so 82.3 degrees. And so you can kind of see if you want, I'm trying to get the glare out a little bit. I take the cosine inverse of 0.134 and come out to be 82.3. So 3 theta is equal to 82.3 degrees. I'm going to add 360 to that. That's 442.3 degrees. I'm going to add 360 to that. It's 802.3. There's also, that's the first round, that's our x hat. Cosine is positive. At quadrant 4, it's going to be 360 minus 82.3. That's 360 minus 82.3. It's going to come out to be 277.7. So 3 theta is equal to 277.7. Add 360 to that. I get 637.7. I add 360 to that. Comes out 997.7. So there's just 6 solutions. So there are 6 solutions now. Okay. Solving for theta for the first equation, 82.3. 82.3 divided by 3 comes out 27.4. Is that one of my answers? Perfect. 27.4 degrees. I wrote in the back of the book. I wrote it down. The second one, 442.3 divided by 3 comes out to be 147.3 degrees. 0.4 degrees. Yada, 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 yada. So that's going to be divided by 3, divide this by 3, divide by 3, divide by 3. So you're going to have a total of 6 solutions. Okay? Everything else is tedious, just calculation. Good luck, study hard, thanks.